Alright, so I think I'm recording. Now this one's a little bit interesting because we've seen that with three terms you can sometimes do the x method, but you can't here. And the reason you can't, the degree of this term is 3 and half of 3 is 1.5, and that wouldn't be a polynomial function. This would have to be a degree 4 and 2, or this would be more familiar, your x squared and 1. But see, it's not. So we can't just jump right in and factor it. Now, actually the directions are wanting us again to do our rational root theorem. So we have our factors of our constant term. And that's plus or minus. We love it when it's a prime number because it's just 1 in the number itself. And the leading coefficient, when that's 1, then it's just 1 or negative 1. So this is my list of possible numerators. This is my denominator. I can generate a list of possible rational roots. So my list of my possible, no guarantee that any of the numbers in this list will be a true solution to this equation. It would be a true 0. List possible rational roots. And since it's divided by 1, this list is just generated again, and we've got 1 or 2, well, positive or negative 1 and positive or negative 2. So now we want to look and see, we know, we already commented that we can't factor it, but let's look and see if either one of these is a 0. I think by inspection you can see that if you plug in 1, you'll have 1 plus 2, which is 3, and this negative 3 times 1 is a negative 3. So 1 definitely works. So I want to do synthetic division with 1. Now, this is in standard form, but it's missing terms. It's missing 3, 2, 1. It's missing an x squared. So I've got 1, and then I've got 0, and I've got negative 3 and 2. So I'm expecting to get a 0 here because when I plugged in 1, I got a 0. Alright, so that tells me this left-hand side of this equation factors to x minus 1 times 1x squared plus 1x minus 2 equals 0. So let's see. We might not be able to factor that, or I think that we can, though. We've got x minus 1. X times x gets me x squared. Because this is a negative 2, one of these is going to be positive and one's going to be negative. The larger in magnitude is going to be positive because the middle term is positive. And a positive 2 times a negative 1 should do the trick, right? And notice you've got an x minus 1 and another x minus 1. So it was of degree 3. All of the roots are rational. We've got x equals 1 that has a multiplicity of 2. And we've got x equals negative 2. So we have found all of them. We generated the list that they wanted, and we found the rational roots of this equation. Hope that helps.